Have a great time on stage. Where's Grubbs?
So one thing Mark didn't say is I do speak German. I was going to try to talk German on stage, but I'll totally make an ass of myself if I do. Ich habe einmal in Düsseldorf gelebt, deswegen kann ich schon mal ein bisschen Deutsch. Wenn Sie was später auf Deutsch mit mir sprechen möchten oder Fragen haben, dann können Sie das machen. My German's very broken, for those who didn't understand what I just said. Germans too. If you would like to talk later in German, then feel free to, because I can always use the exercise. I think it was maybe 12 years ago when I lived in Düsseldorf, and I actually did a lot of work in Cologne too, so I'm a little familiar with the city and Carnival. So I run a studio in Madison, Wisconsin. We are a technology, a digital studio. Our primary focus is data visualization and anything related to that, and that includes a lot of data analysis, statistical modeling, and obviously the end result of the visual depictions of data itself. Some of you might have heard of us. I can imagine many of you did not. We're relatively small. But maybe you've seen our work. And what I wanted to start off with here was a couple of older pieces that we've done. And maybe you can put a name to a face. This is a piece we did about a year and a half ago for Wired magazine. It's one of my personal favorites. The whole story is that this is a flow chart showing the number of 311 calls in the city of New York. 311 it's a great service for larger cities in the United States that have it. Essentially, it's a service number. So you call 911 for an emergency if you're being robbed or shot or normal things that happen in the States. But if you have a question, like somebody's parked in your driveway or a tree falls down, you call 311. If you have no idea who to call. In New York, if you see a big rat and he's eating something, you might call 311 and they'll know who to dispatch you to. In August of 2010, the city of New York received their 100 millionth call to 311, and it was a big celebrated event. Wired magazine covered it, and they contacted us to do this piece. And essentially what it is it's 2 weeks worth of data that we use some statistical modeling in order to crunch it down into a 24-hour period. The idea is that this is a day in the life of a 311. Starts at midnight, ends at midnight. Obviously, it's very illustrative. This is for Wired magazine. I kind of like that aspect of it. I like being very creative, innovative with colors and whatnot. But you can see here, there are several layers of information here that you can't really show many other ways in this fashion anyways, not for an illustrated piece. You can see here that this is when people are sleeping. The volume of the calls is very low, and then you see when the city wakes up. You can see little peaks, lunch breaks probably. Some people take breaks at 2 in the afternoon. Most New Yorkers I know don't take breaks very often, so they're just working throughout the day. But then there are some other elements of it. So from all of the types of calls that people would make, we focus on the top 20 categories, and there's one in particular that really stands out when you look at this graph, if you're engaged to it at any rate. And that is the big one that peaks at the end of the days while all the others go in, and that's noise. Obviously, that's a big problem in New York. So it was a really fun piece to do. We had 4 days to do it initially, and they were very generous. They gave us 1 additional day to finish it, so I was happy about that. Very tight timeline. But it really made its rounds. Became a well-known piece. This is Tim OReilly using it at a TEDx event. I had no idea he was using it. He didn't really mention us, but no hard feelings. We also had the piece showcased in the MoMA, the Museum of Modern Art in New York, which was a huge honor. This, along with 2 other works that we've done, and it was a lot of fun. I was actually going to show the cover of the magazine, which had boobs on it, but maybe at the very end, if everyone's feeling asleep or hungry or something. I don't know. This is another piece that we did recently. It's a personal project, one that was fueled more by our own personal interests and our endeavors, and I think it's very important that we try to find time to do our own thing. This is the Bible, the Holy Bible, and this is the book of the Quran. This is the Old Testament, the New Testament. the Quran itself. What happened is that since 9/11, especially in the last couple of years, there's been this constant rhetoric, especially in the United States, but also in Western Europe, of this sort of anti-Islam, anti-Muslim ideology. These conservatives especially coming out saying Muslims are all violent and the Quran is a book of violence, and we hear this all the time. Especially in the States, the conservative half of the country just really focuses on the violence of the Quran. I grew up in the Deep South, in Arkansas to be exact, and a very, very religious place. I'd never want to go back there again, except to visit family and whatnot. But it was interesting because I remember as a child this fear that was being taught. I mean, it's part of the culture, this religion. And this hell and damnation and Deuteronomy, I just remember all these violent episodes of the Bible, and I was thinking, if the Quran is violent, is it more violent than the Bible? I don't know. And I can't read the Quran. I can't just pick it up and read it. It's very complex and complicated. So I built this app, and what I did was I loaded in the King James Version. I'm glad that we can see this. You can see like little bitty ticks, like squares, like rectangles, I guess. Those each represent a full verse. And you see highlighted ones that are a little bit darker. Those are the ones that contain the search word up there, fight. And what we also did was we returned a synonym API that shows similar words to fight. So we're not just looking for that singular word, we're looking for a word similar to it. It's not a perfect system. I think the API we're using was called WordNick, and I have some major gripes about it. I think if you type in fag or homosexual, it returns Australian, which is like... But a good thing is Australian will definitely not turn up in either of these texts, so we don't have to worry about it skewing our data analysis. Really interesting piece. You can see the graph up here we've got some statistics. So you can sort of see the relative volume of how much the Quran might use a word versus the Bible. You can, in theory, read the entire text of the Bible and the Quran in this single app. And that was sort of the purpose, is to give people this full access, to have everything in as much context as we possibly could. This is me. Instead of me actually up here typing it, I did a little screen grab. So this is war, and you can see, okay, the Quran, relatively speaking, uses war a little bit more. Peace, Bible uses a little bit more peace. I mean, there's sort of like these analysis, and you can see these words related to peace. Jesus, obviously, is going to show up in the New Testament a lot. Allah should only be in one. And then some other really interesting stats and figures that sort of came out of this. Like terror was the main thing I wanted to see. And we can see the Quran might use the word terror a little bit more. The frequency, the Bible, if you see at the very top, 448 occurrences of a terror-like word. The Quran has 170. There are different types of statistical or ways to perceive this data, and I think that's very important, and we wanted to try to offer as much as possible. And you can see as I just rolled over this, you can actually read those verses, and there are just different ways to filter that data to sort of refine your search results. Forgive was a really interesting one. The Quran talks about forgiveness much more than the Bible. And then I would type in words, maybe I'm just curious, and so suicide bomber is obviously we're not using the word bomber, but suicide showed up nothing, and then I realized through my own research that word did not exist in this time. And then skateboard. I'm like, damn, I really wanted Jesus to ride a skateboard. The reason why I'm showing this, it's a valid argument. When you build something and you build a tool that's going to work, not only do you want to test it for results that you're exploring, you also want to test it that it works for things that you don't want it to show. So, for example, if it did show up skateboard anywhere here, I would know that something was very wrong with the system. But I'm not here really to show our previous work. I want to show some new work. And before I do that, I want to talk about the brain. No, I'm not going to have pictures of zombies up here or anything like that. I would like to. But I actually want to talk a little bit more about how the brain works, and I'm going to have a little bit of biology here, so sharpen our biology pencils. The reason why the brain is important to me and to us at the studio is we're constantly trying to find ways to understand, refine, and improve the ways that we communicate the information that we visualize. There's a lot of argument, there's a lot of debate There's a lot of discussion out there about what's the best way to visualize information. On one side of the spectrum, anyone that does data visualization, is there anybody here actually that works in a data viz community? Like that does data visualizations? You sort of do. Fractal style, I love it. So the whole deal, not too many people here, that's actually good. There's this whole debate in the data viz community. There are two sides of the spectrum. One side is sort of this business intelligence, business analytics side that wants to build or has already built these sort of rules and system that you must follow. And usually it involves bar graphs and proven systems already in order to represent data. And there's another side that deals with more innovative ways to try to be artistic, a little bit more creative, and push that fold. Sort of ask those questions and bend the rules and see if there's more ways and more perspectives that we can do this. And I'm always trying to understand, well, who's on the winning side of that? And I don't think that there's a definitive answer. It all depends on what it is that you're actually doing. But coming back to the brain, I'm just going to go through this sort of quickly. Very interesting stuff. So this is a neuron. Our brains have lots of them. And what happens within our brain is that there are all these neurons, and they connect to each other, and they communicate to each other in certain ways, building what I call constellations to make meaning of the world around us. Obviously, you don't have to learn all this stuff, and this is not from me. This is just like a Google image search. I just wanted to kind of show a little bit of these complexities. It's this center nuclei, and then it branches out, and those branches are really crucial. In our brains, we have approximately 100 billion neurons. The other day, I was trying to build like a visual representation of how much 100 billion is. And I had this processing tool where I had like 100 squares on the screen, and it was going to like zoom to the top left square and keep zooming until the 100 turns into 100 billion. And that animation was like 10 minutes long, and I was like, forget it. Like, there's nothing I can do to really help illustrate how much 100 billion is. It's a very high, it is an unfathomable number. Between those neurons, all those branches, there are about 100 trillion connections that are made, sort of a combination throughout our brains, and it's a really important aspect to realize. Don't worry, I'm going to get to my point here. I'm not going to talk too much biology, but it's fascinating stuff to me, is the way these neurons connect or communicate with each other are two ways: electrical signals, by sort of sending these spikes of electrical stimuli between each other, and there's chemical reactions. By reinforcing both of those, the signals and the reactions, is how memories and these sort of connections are made and meaning. This is a really interesting graph that just shows how neurons evolve. We're essentially born with 100 billion neurons, and we essentially have that number throughout our life. What changes between those neurons are those connections, those branches. They refine, they grow throughout the entire brain. They connect to other neurons, and what happens here, like this is at birth. You see that there are a few neurons on the screen. It's a really bad resolution, but it makes the point. Very low density. The branches come out, and there's a rather high density when we're young. And then what happens is the density sort of reduces a little bit as we get older. This is, to me, extremely fascinating. Why is that? It's not because the branches get old. It's because connections are made and they're solidified, and then the connections that aren't needed are taken away. So, for example, you're learning to ride a bike, and all these connections are trying to all these neurons are trying to establish a synapse or a connection within your brain while you're learning. So you're going sideways, you don't know how to balance. This is your brain working at that. And then once you learn how to ride a bike, and once you master that, there's a very distinct constellation that's made. And all those sort of mistaking branches are eventually they go away. And so what happens is this constant refinement. Another fact is in one part of our brain, the primary visual cortex, it's the very back of our brain. In the first, from age 2 months to 4 months old, we're just small babies at that time. Over 500,000 synapses are created every second, which is phenomenal. I mean, our brains are extremely complicated, and it's capable of processing extremely complex information without us fully realizing it. And to sort of show that as an example, I have this. When we all look at this, we can tell that circle is not in the center. If one of us here does think it's in the center, we might need to go see somebody. I'm I'm sure there are some people with disorders that see that, but the whole point is that we can see it's not in the center, but why? I mean, it seems obvious to us, but it's actually a very complicated process. It's a learned process. Our brain is telling us through all these tensions and forces of this square that circle is not in the center. Something is wrong with that. And this is why designers constantly focus on alignment, why that's so crucial. Because if something is just slightly off-center, we may not consciously be aware of that, but our brains are. And that's why this alignment issue is such a crucial aspect. So our brains can detect patterns and sort of anomalies in these patterns. Interesting. But there's one other element of our brain that I think is far more crucial. This is our ability to imagine. When we're looking at this, I was really fascinated when I first saw this, trying to make sense of, like, what is this? And as I was reading, and the author of this book told me what this was, it's sort of like an enlightening moment. So we're trying to decide, our brains are trying to figure out what it is. We're having all these different combinations. Is it tire tracks? I don't know. A hair follicle in a microscope? It could be. But what if I was to tell you it was a giraffe moving behind a window? Suddenly, we can imagine that. We all know what a giraffe looks like. We all have different images of giraffes that are programmed in our brain. We all know what a window looks like. We know what it feels like or what it looks like when we're in a train or something, that something moves by a window. I think that's a very important aspect. We have this ability to imagine and fill in a much bigger space than what some people realize. And I think that's really important too, a very important aspect to keep in mind. Just a few more slides about the brain. I'll show you some work. But this is a really interesting neurological map. This was done by the New York Times, not by us. And what it is, it's a fascinating project. There's a project trying to map out the brain called the Open Connectome Project. This is part of it, partly called the Open Worm Project, and this is a particular tree worm called C. elegans. Why is this important? It's one of the very first neurological maps that we have of any creature. This particular worm does not have a specific brain. What he has is neurons that are throughout his body. And scientists, they took the world's sharpest knife and they cut it into these tiny, tiny, tiny pieces, and then they were able to take that and map out all of these neurons and these branches throughout. It's very simple. But you can see here, this is 302 neurons throughout the C. elegans, 9,000 connections. Our brain has 100 billion neurons and 100 trillion connections. Just to understand how complex it is, we are probably at least a decade, if not several decades away from being able to truly effectively map out the human brain, to understand specifically how some of this works within our brain. When we remember things, there are several ways that we use to remember things. Like, one is through repetition. When we're going back to children, I have a 4-year-old, so I'm always talking about kids. It's always fascinating to watch this development. But this repetition, learning the alphabet, we're not inherently capable of learning an alphabet. Not the same way that we would be inherently afraid of a tiger if it jumped out of a jungle and started chasing us. That's sort of an instinctual genetic learned trait. Alphabet is not. And what happens when we learn the alphabet is we repeat it for several years early in our lives. And then at one point, it's mastered, and we can read. And we can learn other alphabets with that aspect as well, but it's this repetition, and what happens is these neurons, you're forming these connections by repeating and solidifying these connections between these neurons. Another thing are new events. When something new happens to us that formulates these connections within our brains, through time those connections are lost, unless it's dramatic enough to really solidify or something that we need to remember for a certain reason. And another one is odd methodologies. These are just a few examples. Odd methodologies, any of us who've studied for tests know what I'm talking about. When you make a song to remember certain bullet points. I think when I was in elementary school, we had to remember all of the presidents of the United States. The only way we can do that was a song that had each president in there. And so the rhythm and the way that the brain was stimulated through the rhythm and these different connections helped us remember that. We don't need to remember our first kiss, or we don't need help in remembering our first kiss. It was a dramatic experience for most of us, maybe not all of us, or what we were doing on 9/11. I remember very specifically what I was doing on 9/11. I was living in Croatia at the time, and I was driving in a car from Dubrovnik to Zagreb, and I just got this flood of text messages and phone calls on my cell phone. And I remember this feeling for the rest of the day. It was very emotional in that regard. And for Germans, anyone here is old enough, and most of you look like you're fairly old enough, to remember the Berlin Wall and when it came down. That was a life-changing event for Germany, a very, very important event. It changed the entire way that Germany was perceived by the world and how Germany perceived itself. So basically, what I'm bringing up is the brain is complex, and we need to use it in that regard. And we need to learn how to create memorable visualizations. This is a piece that we did for Popular Science magazine. And what it is, it looks like spaghetti code, or spaghetti lines when you look at it. Spaghetti code. You know what I'm doing all day. So the whole point of this particular story and this particular piece is that the CDC, the Center for Disease Control in the United States, has this massive problem every year in trying to forecast and predict influenza, the trends of influenza throughout the season. And this is why. This is almost 10 seasons put on top of each other. We took the CDC data and Google Flu Trends data to sort of show their similarities. Okay, they're synced up, but really from every year when these peak, and what these percentages represent are the percentage of people who visit a physician for the flu. And so you can see, in one year it peaks early on, the next year it peaks in the middle. There are double peaks sometimes, and the CDC has to have this information. They have to predict something in order to have enough medication, enough people staffed to deal with that. And we even know several years ago when in the United States we ran out of the flu virus, or the vaccinations for flu. It was a bad prediction, but there was also some logistical problems from a British supplier. My whole point, too, is that, going back to this, a really crucial point, we're offering two perspectives. One, this is the story. The story is it's very hard for the CDC to predict flu data. This is why. I don't care about giving people specific XY axes information. This is a statistically sound graph, but you're not wired to remember all those variables, and that's not the point. If you try to memorize those variables, then go for it. But the chances are in about 20 minutes, those are gone. What I want to communicate is a storyline, and that's what we do. That's the main aspect. Over here, we break out the same graph, and we break it out for another perspective. And what we try to do, too, you saw with the Bible and the Quran, is we try to offer as many perspectives as we can. And I think that's just an interesting aspect. We want people to be interested and engaged. You can sort of see behind this a little bit. We created some 3D viri behind the bar chart. Why do we do that? And some people would argue you should not decorate this in that way. That's wrong. But in this case, it's not in the way. It's a visual reinforcement of what this graph represents. It's a graph about the flu virus. So we added the flu virus behind it, consciously realizing this wasn't just saying, well, let's make it look prettier. This was actually saying, let's give another visual element on this that's not hindering the person's ability to view this, but that helps sort of reinforce what this is about. The other aspect is, we think visually. We communicate visually. We use metaphors all the time. I was trying to remember a couple of German metaphors, but I really couldn't. But in English, we have quite a few. Germans are full of them, but I don't even want to try them. But, like when you say, stop pushing my buttons. You're not pushing buttons on me. It literally just means stop pissing me off. And pissing me off, there goes another metaphor. Or you're barking up the wrong tree. I mean, literally, it's almost, we're almost stuck to metaphors. It's a very effective way to communicate an idea or something to another person just by talking to them. It's a visual metaphor. If I was to tell you, well, my flight yesterday was 14 hours. The last time I flew was 16.2 hours. And one time, a while ago, I was en route for 32 hours. You're not thinking necessarily in a bar chart, unless I try to illustrate that in your brain, how that might look. you're not thinking that at all. You're thinking more visual elements. Or sometimes it's just a matter of a subconscious realization like, wow, 32 hours is a long time. Like, you were probably completely tired. And that's a really important aspect to realize. And we've been communicating visually for a long time. I don't even think I need to explain this. I mean, this was the kind of communication that was created before languages were systemized. The other aspect is that art and the lack of it is a symbol of our culture. And I think that aesthetics is a very important aspect to constantly pursue for those inclined to do it. I don't think that this is a rule that people need to set. I'm not trying to do that. But you shouldn't try to bash art. When we're trying to understand our history, medieval ages or ancient Greece, how could we understand it by completely ignoring the architecture that the Greeks did? Or by the philosophy and some of the literary works that were created during that time. It's a very telling story about how people lived and what they thought. This is an example, too. One of my more favorite works, this is another religious one, don't think that. It's 1600s, very important time. Caravaggio was a brilliant painter. This is a story of St. Peter, crucified upside down. Because he thought he was unworthy to be buried like Jesus. And this painting says so many stories about this time. I'm not going to go into it in finite detail. But the realization is that at this time, a majority of the population was not literate. And before this, it was even less literate. And so what did people do in order to communicate and tell stories and help people remember things? And there were two primary elements. One was storytellers and theatrics, and the other one we see in a lot of churches are paintings. And those paintings help create that sort of biblical story that people can take home and remember. And by adding these other visual elements, these specific details, especially ones like this that were a little cutting edge for the time, it almost provokes people to think about it. So now to a little bit of work. This is some very new work. I haven't showed this to anyone before, and this is the very first time I'm showing work that I'm actually calling data art. Most of the stuff we do are specifically data visualizations. I would like to think that they inform people who are engaged in them, but this is one in particular that it's art-based, and one that we had really a lot of fun doing, and we're actually just kind of wrapping up right now. So the McKnight Foundation is based in Minneapolis, Minnesota. They're an art foundation, and essentially they've been around for 30 years, and what they do is every year they support artists and by giving them grants and fellowships to support what they're doing. And they had contacted us because they wanted some sort of visual depictions of their artists, and all they had were resumes. And the interesting aspect is we couldn't show the artists' names, but we had to find a way to visualize these resumes. And I was very interested in this because it's very art-focused, and they wanted to commission us to do this. I was like, great, okay, we definitely want to do it. So send us the resumes over, and this was like one of them. I'm like, oh, there's not a lot of text in this one. And then we'd get another resume, or say, oh, there's a lot of text. This is well organized. And we'd get another one, and it's like, dude, who has a 28-page resume? I mean, that's insane. Like, how the hell are we going to break this out? And what we did, I went back to the McKnight and I said, listen, we have to spend quality time up front analyzing this data. And by data, I mean resumes. If we don't find a very solid way to break these resumes out in sort of a uniform format, these visualizations will fail, like what we're going to do, because we need to basically convert all of these resumes into Lego blocks that we can manipulate and do things with later. So we built this content management system, just a very simple one, PHP MySQL. It took like a couple hours to build. And we designed the database. And what we did was we would refine this. We'd start to add a couple of resumes and refine it. And once we got it to a certain place, then we brought on a couple of data entry people, because they're much cheaper than we are. And if you train them effectively, then by all means, they were very awesome to work with them. And so this was one of the very first results of this. What this is I call this like an artist star. Is there any way to turn the lights down just a little bit? Maybe, I think he's up there drinking a Kolsch or something. Yeah, okay, thank you. A little bit more? Yes. Okay, thank you very much. So these are artist stars. The idea was to build visualizations where all the artists can be together, but also by themselves. And so this is sort of an annotated version of this. We can see this particular artist. Here's a story. It's a circular diagram. Starts at the top at the beginning of their professional career. It goes all the way around to the end of their professional career. Throughout it, there are these spikes, and those are when events happen. So you can see here in 2001, they won 3 awards. They had 2 performances. Each color represents a type of event that happened in the artist's life, whether it was an exhibit, education, performance, award, teaching experience, etc. This is another one with a little bit more. Obviously, what we did was we normalized that data from the center to the outer edge. So we always wanted the biggest spike in the artist star to always be at the same point for all of them. But the thing is it's dynamic in the sense that we build the system, and then what we do after that is we pull in the artist information, and sort of the way I explained this to McKnight was we let the artists create their own through their own experiences. It was really interesting. I mean, I thought the results were quite interesting. This is conceptual. Like I said, it's data art. I'm not trying to inform you from statistical analysis so that you can make better decisions in life. This is particularly to entertain and engage you and get you interested in this and have a little bit of sense of what these artists did. So you can see through the exhibition one of this artist, it spiked. So they just went in and out of exhibits throughout their professional career. It wasn't consistent. The purple is teaching experience. So you can see at the beginning of their career, they had a little bit more. They had some here, and then suddenly it became a regular thing for this artist. And that's sort of the story to tell with this. This particular artist was a very, very active, industrious artist, doing a lot of different things a lot of times. We built this using HTML5, so there's this sort of animated sequence that helps define the time series of this. And that was, it's a lot of fun when we create something static and then we sort of bring it to life and show that sort of depiction. And it's great because there's such a high volume of this, and it's so modular you can add in new artists all the time. With this particular data entry tool that we did, though, we had one data point that was extremely crucial for us. And it literally made some of these resumes take days to enter. That 28-page one, I think, took 2.5 days to enter. And that is because we were tagging geolocations of all the things that the artist did. So if they had an exhibit and we had a name of a gallery, usually you don't have the addresses in your resume. I wish there was a standard for that for this particular case. But we had to do Google searches and use the Google API, the location API, to geotag the actual locations of this. And so what we came out next with was, so we had the stars first, and now this is like a life thread. You are the first guys I'm showing this to outside of our studio, so later on I would like some feedback. If anyone is inclined, I'll buy you a beer. Everybody. I'm kidding. No, don't. It's a joke. So what's interesting about this, same with the stars, they're all unique. That's the beauty of it. The artists create their own by their own experiences. And you can see here, this is sort of how the system works. They're all unique, and we just plug in a new artist. They're all different, and it looks different. I mean, you can sort of tell which ones traveled around the world more or which ones didn't. Sort of a fast motion aspect of how this actually works. We use 3JS, which is a JavaScript 3D library, and you can sort of see here how this is mapped out. And then once it's created, we have a 3D model of the threads, and you can spin it around and do fun stuff with it. Zoom in. Just sort of added these extra visual elements. It was a lot of fun doing, and you can, it gets really, you find these really weird anomalies with all these balls trying to group over each other. It was fun actually doing this. What I want to do, though, is show you a final result of one of these artists that traveled around the world, and I just want you to sit back and enjoy and watch this for a second. So we're launching this website. Oh, thanks. We're launching a website in hopefully June. That's the plan. But we're actually showcasing all of this, and you can see it and experiment and play with this. It was really a tremendous amount of fun actually making this, and yeah, I can't wait to see where it goes. We're planning on putting more artists in there and hooking up with more organizations. One of the last pieces I wanted to show is a fun piece, and there's a reason, because there's a treat at the end. Probably not for everybody in this room, though, but for fast ones who use their elbows. But so for this last holiday, we like to do things for the holidays for our friends and family. And what we did for this last holiday was we made these holiday cards. We used processing to generate this particular pattern. This is sort of another pattern of this. What we did was using fairly basic laws, geometric laws, we went through this entire thing and we drew a link between two of these dots. And we iterated that, and we created a unique pattern for every card that we actually sent out. It was a lot of fun. I wanted to actually talk about some of the math that went behind this, but instead I decided to print them out, and then I have the source code behind that actually illustrates and points out some of the code. Wait, somebody pointed? You have to get in touch with me later, because well, now you said it. Now you ruin it for everyone else. I have a couple of shirts and stuff I wanted to give away. We're moving to Berkeley, California this summer from Madison, so I have a lot of stuff to get rid of. Some of those being shirts. So I packed as much as I could. So anyone else who recognizes what's in there, you can tweet me or email me or something, and I'll give it to you if I have your size. I don't think I have your size, though. But yeah, you see play. This is the mental trick. Once you see play up there, now I ruined it. The first people who tweet or email me get a shirt. But once you see it, you can't shake it off. It's there. You know it's there. And so every time you look at it afterwards, you can't not see it. And I tried this trick many times, but unless you're really avoiding it, you always see it after that point. Does anyone here not see it? You don't? It's in the middle, like right above me, but like center, but towards the top. Yeah, you'll have to get one of these and play with it later. Maybe smoke something or... Oh, wait, we're not in Amsterdam. Damn. You can also download the source code here. Pitch Interactive Holiday Card, where we have the full source code. This on the back is like the basic logic. If you plug that into processing, you'll see actually how it works. And I just have a few minutes left. And I think a last point that I really want to make, anyone here who wants to do data visualizations, there's one important tip that I want to tell you. And I like to use the word tip because I don't like to create rules. I think that we need to create our own rules as we're learning, because all of our brains are different. All of our neurons are connected in different ways. So we all learn very differently, and I think that's a very important aspect. Depending on what you're doing with your data visualization, we need to understand what it is that we're duplicating if you want to have a successful visualization. The more you research into it, the better. One example I keep coming back to is like Leonardo da Vinci. The illustrations that he did, the mechanical illustrations of muscles or people's faces, he showed an expert knowledge in this field because he studied it day and night. He studied it endlessly, tirelessly, until he understood it fully, and then he was able to sort of break these mechanics apart, show the gears and how those work. I think that's a really important aspect. If you're just observing and you observe a little bit and then you create a visualization based on that basic observation, the chances are that what you create in the end is not going to be near as effective as it would be if you really put some time and understood different perspectives of that element as well. And that's all I have. Thank you very much for coming here.